Put those away, please. Or finish them later, one of the two. All right. Review questions. List the angles in order from least to greatest. Please note that no, this triangle is not drawn to scale, is it? Not even close. Okay. So look at it. Think for a moment. That's fine. You can just answer them out loud. That's fine too. Okay. What is the smallest angle? Shout it out. 1, 2, 3. Why is B the smallest? It's across from the smallest side. Okay. What angle is medium? 1, 2, 3. Oh. Biggest? 1, 2, 3. G. Largest side, largest angle. Yes. Make sure you put, so, angle D, angle O, angle G. Okay. All right, on number 2. List the sides in order from least to greatest. And someone's going to say, Mr. Kuhne, you didn't give us the third angle. Yeah, you can figure that out on your own. Okay. So, what's the smallest side? Shout it out. 1, 2, 3. AB, because this is 20 degrees, so this is the smallest. Okay. AB. What's the medium? AC.
X can be.
What is the largest side? Okay, now here's the cool thing. I'm going to ask you a question. Could X be 8?
No. No, has to be greater than 11, but smaller than 25.
It can't be 8 because then the smallest side is not across from the smallest angle, is it? So therefore, AB is 11. AC is X. BC is 25. We can get a range of values for it, can't we? We don't know exactly what it is, but we can get a range of values for it. Okay. Now, some people don't like to write it like this. Some people like to write, hey, X has got to be less than 25 and X is greater than 11. Is this okay? Everyone's like, I don't know. Is this a trick question? Yes, this is fine. But if you're one of those people that are like, I don't want to write that. I don't even type full words when I'm texting. Give me the short version, Mr. Kuhne. That's perfectly fine. Okay? So make sure you have the less than or greater than signs going the right way. Okay? I've had some people do, oh. Well, Mr. Kuhne, X is greater than 11. No, that's 11 is greater than X. And is 11 greater than 25? No. But we do it this way, 11 is less than 25. That works, right? So yeah, don't do it wrong. Okay. Now, here's the next question. How many of you have ever done that game where you put your head on like a bat or something? You spin around, 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 spin around. You do it again and again and again. Okay. You do it again and again and again and again and again, and then you have to run back, right? Okay, here's what happened. Okay, Curious George is right here. Curious George. Let's see here. There, monkey face.
Just watch it.
Okay, Curious George right here. He runs over 9 feet, puts his head down, and spins, 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 and then gets up and starts running 6 feet, and then all of a sudden he realizes, wait, that's the wrong direction. Oh, oh. Gotta go back there, okay. And then he starts running back. How far did he run back?
Well, I'd say
Wouldn't it be smaller than 50 over 15?
smaller than 15 feet.
He says smaller than 15. You said it's got to be over 15?
Oh.
I'm just asking. Just ask what you said.
Greater than 9
Greater
or
than
less
9,
than
smaller
15.
than 15.
Greater than 9 and less than 15? Okay. Now, he ran over here, spun around, his head was on the bat. Okay? Spun around, then got up, and then started running 6 feet, and then realized he's running the wrong direction, and then he ran back along the orange path.
Like that, not in the triangle.
No.
Okay.
No. Okay, so now here's the thing. We don't know which angle he went at, did we? We can't figure it out exactly, but we should be able to get like a range of values, kind of like over here. Okay? Because maybe he ran over, put his head on the bat, spun around, then started running back, and he was pretty close. He did the, then ran back, okay? Maybe he did that. If you've never watched this, it's absolutely hysterical. You should definitely try it,
We
okay?
should do it. We should play.
If we have time at the end, sure.
Yes.
So, here's the thing. The angle could have been obtuse. It could be acute. We want to know, what does X have to be between? Let's get a range. Okay, it's got to be bigger than this, but less than this. So just think for about 30 seconds. And you're going to share with somebody nearby you, sitting nearby you that you don't despise. Okay? And then we're actually going to try some of the numbers, okay? Using your ruler. Okay? So just think for a few moments. Okay, 3, 2, 1, my turn. What do you think X has to be smaller than? 15? Then we have something bigger or smaller, and anyone got a different number? And we're just going to agree with the masses. I'm going to stand up for there. Yeah?
Could it be like 37?
Okay. So you think it could be 37?
No, it could be smaller than 37.
Okay.
But we could do any
Because that
number.
falls into the grade of smaller than 15.
Okay, so we're looking for an upper bound here. Do you think the upper bound is 15?
Yeah.
Okay, yeah?
Probably 16 because 15 is great, and then 10 at all, it could be 15.
Okay. So you think X has got to be smaller than 16. So it could be 15.5. Okay. All right. What do you think X has to be bigger than? Bigger than 9?
No,
Bigger than 0? I'll agree with that.
bigger than 0.
Bigger than 6?
I think that's bigger than
Bigger
than
Well,
1.
it's not like our hardest was the longest side.
It could be 3.
So when
it's
the
bigger
X
than
has to be
2.
over 50?
Do we think it can be bigger than 3? Someone say 3?
Yeah.
Okay. So here's what you're going to do now. Take your ruler, take a sheet of paper. You're probably going to want to do 9 centimeters instead of 9 inches. Try some different numbers. We're testing your conjecture. Okay? We're testing your conjecture. Try some different numbers and see. Can you do one that's, so someone said it can be it's got to be less than 16. If you think it's got to be less than 16, try to make it like 15.5. Okay? Got a question? Less than or equal to 15?
Yeah.
Okay. 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 So when you say less than 16, that could be anything less than 16, which includes 15.5. So x must be smaller than. So it doesn't have. So you're saying it doesn't have to be smaller than 16. Is that what you're saying? Could not be 15.5. So it's got to be smaller than 15 or equal to 15? Okay. Okay, so we got one person saying less than 15, someone saying less than or equal to 15. Yes, sir.
Couldn't the number the x's change because like the second, like you know how he goes in a straight line and he stops and then he goes the second time? Like the second time could be this and then he only has to go this far, or it could be here and then he has to go all the way over here.
You're right. Yes. So it could be anything between. I mean, it could be some super big and some super small. So we're kind of looking at the case of, oh, what if it's way over here? It's got to be bigger than what? Or if if he ran totally in like the wrong direction, if he like started running east or west and then ran more west, then he'd have to go even farther east, right? So yeah, we're trying to get a range. So measure that third side. Try several of these. Let's just do one. Decimals are fine. Decimals are friends.
Freaking heck, that's a big angle.
Right with that, what was like almost straight out, what was almost straight out.
Try different scenarios. Like it went straight out and he almost ran straight back. Maybe Curious George went like this way and then came back like this way for 6 feet. Then okay. How far is this third side right here? What if you went almost straight out? So 9 feet and then almost 6 feet straight out again. One more minute.
Yeah, that's not the two.
Okay. Let's talk it out here. It's got to be larger than 0, obviously, right? Does 1 work? It didn't work? It's not possible?
Greater than 1, yes.
But would 1 work?
Yeah.
If I go 9, try this. Try going 6 here, and then try going 1.
Oh, no,
Okay, so 1 doesn't work. Did anyone find a third side smaller than? Oh, I'm sorry, bigger. And find something smaller than 9. Yeah. Check out your numbers. 3.5, 3. Oh, so you found something smaller than 6 too. Okay. 3.2. Did anyone get anything? Did anyone get anything smaller than 3? Did anyone get exactly 3? How'd you get 3? Was it a triangle or was it like right on top of each other? Just asking. Was it a triangle? Okay. How was yours? Okay. Okay. Why do you think it should be 3.0001?
It was 3, 6, and 3. It would add up to be 9, which means you had to equal the other 9. And you had to be right on top of each other.
That's true.
What do you think?
So does that mean that it could be 3.00001?
It can be.
It just has to be, it just has to be over 9. It has to be bigger than 3. Better probably. Bigger than 3.
Bigger than 3? Okay. So we're saying it's got to be bigger than 3. Is that what you're saying?
Yeah.
Larger than 3. Okay. It's got to be larger than 3. It can't equal 3 because it would be just be a straight line.
Yeah.
Like it would be okay. So here's whole thing's 9. Then this one it had to be right on top, and that would be 6.
Yeah.
And this one right here would have to be 3.
Yeah.
That's what you're saying?
Yeah.
Okay. You're correct. It has to be slightly bigger than 3 for this reason. Here's how I think about it though. I think about it in terms of doors. Four feet. Okay? 4 feet. 2 feet, 2 feet. If 2 feet plus 2 feet would make a triangle, this door wouldn't close, would it?
No.
But when the 2 feet and 2 feet are actually touching, the door is closed. But is it a triangle now? If I look down at the top, am I seeing a triangle?
No.
That's how I think about it. I totally dig this too. I've had some people say, oh, this is like a drawbridge. It's 6 feet and then 3 feet when it's connected, but if you lift up the drawbridge ever so slightly, it's not connected anymore. There's going to be a little hole for the boats to pass through. I thought that was a good idea too. Okay. So it's got to be larger than 3. What's got to be less than? 15?
It's always the most. But are we saying that it's predictable or just?
If it was 15 and the 6 and the 9 wouldn't have been the angle. It would be,
It's
it would be 9 and then.
It is
Yes,
6.
it is.
So this is 9, 6. Then going back this way would be 15 if it's perfectly straight.
Yeah.
But you're saying if I scoot it up a little bit like this, it's going to be less than 15?
Yeah.
Okay. Interesting. Here's how I think about it. So I like running. I run 9 miles and then I run 6 miles. Okay? I turn just a little bit down a different road. Okay? Just barely, slight turn. I run 6 more miles. Okay? Let's say you got a runner here. Isaac likes to run, right? Isaac's like, psh, I don't want to go that road. He's going this way. He took the shortcut, right? The shortcut is always less than the other 2 sides. You have just discovered the triangle inequality theorem. How did we get 15 right here? It was 9 plus 6, right? How did we get 3? Okay. The triangle inequality theorem is this. This is the big idea for today. Put this in your notes. For any triangle, A plus B has to be less than C? Or which is it?
Greater than.
It's got to be greater than C. A plus B has to be bigger than C. 2 sides have to be bigger than the third side. Now it also works for all the other ones. This plus this has to be bigger than X. B plus C has to be bigger than A. A plus C has to be bigger than B. That is the big idea from today. So on this one right here, if we were to check this, okay, say, okay, fine. 2 sides have to be bigger than the third side. 9 plus 6 has to be bigger than X, correct? X plus 6 has to be bigger than 9. X plus 9 has to be bigger than okay, and then let's solve them. This is really saying X is less than 15, or I could say X is less than 15, right? 15 is greater than X, or X is less than 15, same thing. This one, subtract 6 from both sides, right? And we're gonna get X is greater than 3. This one, subtract 9 from both sides. X is greater than. Do I need to worry about that one? No, because this one takes care of it, right? If X is bigger than 3, it's got to be bigger than -3. Okay, so what does that tell me? X is greater than 3, and X is less than 15, or you can write it X is between 15 and 3. That's cool. This is also cool. Both answers are correct. Yes, ma'am.
What would be the easiest way to find like the 3 without having to draw a whole bunch of them? No, for the larger group.
Without having to draw what?
Without having to draw a whole bunch of like different triangles.
Okay. What pattern do you see happening here? We got two sides, 9 and 6.
Well, I see the 2 like subtracted by triangles.
Uh-huh.
Does that work for everything or is that just for that one?
Yep. Because if I take that third side and subtract this side, it's 9 minus 6, right?
Yeah.
So that gets me the bottom number, always. Yep, subtract them, add them. We could rewrite this, x is greater than 9 minus 6. Or really, that could be any pair of sides. So you can think of this as, hey, two sides have to be added to more than the third side. I like to think of this as the shortcut theorem. The shortcut's always got to be less than the other two added together. Sure, we could call it the triangle inequality theorem and sound stuffy and elitist, or we could just call it's the shortcut theorem, Mr. Kuhne. The shortcut theorem. You know, two sides, the shortcut's got to be shorter. Okay? Turn to someone nearby you, put it in your own words. When you put it in your own words, your brain has to think about it better, and you're more likely to remember, okay? Turn to someone nearby you, put it in your own words. Thanks. Go.
Yeah.